Hello, thank you for joining RasPipKr tutorials. I'm Martin Parker, and in this tutorial we're going to look at the sys module. It's a built-in library as part of your Python installation. I'm going to use my Python IDLE shell. You might use something else, that's entirely up to you, but let's go through it in this way. So first of all, you need to import the sys library. So import, and then space, and then sys. No errors, so that means we've imported it perfectly fine, which you shouldn't really get as it being a built-in library. If you want to look at the documentation, call the help and then sys and press enter and double click here, and it will give you all the information regarding functions, etc. that's part of the sys library. I'm not going to go through all this because there's too much and I don't want to make this video way too long. I'm going to bring up a fresh new window, but I'm also going to make it full screen again. I'm going to import the sys library again, but I'm going to look at the functions that is part of the sys library. I'm going to go through a few of these. As you can see, there's quite a few. I want to go through things that you might actually use as part of your code, or to help you with your code, because that's what I'll try and do. So I'm going to look at the argv, the copyright information. You can just call, you don't necessarily need to call the sys import the module to get that, but you can do, and I'll show you the difference. The built-in module name, so you can see what modules you've got built in. I'm going to look at the executable, which is very helpful for when you're if you're wanting to find out your what's called a shebang line that you would put at the top of your script to start stuff off. I'm going to go through a couple of others, modules and version, which is split off a screen, and getsizeof, because you might think it works a different way, but it doesn't. So I'll show you that as well. So first of all, let's look at the version. So sys.version, and you'll see that it's returned 3.7, 0.3 default, etc. And then we've got this \n, and then we've got this bit of text here. And if you notice, this is exactly the same that is up here, like so. So it's telling you that you're using Python, and then it's got all that information that's there. And then the next line, because that's what the \n does as part of a print statement, and then it's telling you that you're working on Linux. So if I call sys.platform, it'll return your platform that you're using. This is a Raspberry Pi that I'm using, which is Raspbian operating system, Debian based, and it is a Linux system that it's working on. Windows, I think you'd get a Win32. Mac, I think it'll probably come back as Unix, possibly, or Linux, I don't know. I don't have a Mac, so I can't say for sure. Try it out if you've got one. Comment it below, give me some feedback on it. Let us look at the sys.copyright to give you the information on there. And as you can see, we've got a load of \n's again, because we're calling it differently using the sys.copyright, whereas if we just call copyright like it's telling you here, you'll get it in a more readable version. So them \n's that you've got here, this line is this line here, so the first one is this one, and then it's the second one is setting it down here, for this text. So that is how the lines work as part of the print statement. Let's look at the sys.modules next, and we've got 91 lines of text coming up. And this, as you can see, is a dictionary with the curly braces. As you can see, there's quite a lot of information here. Let's have a look at oh, there we go, OS, sorry, not OS. It's telling you that it's a module, and it's telling you the location that it is in your system. So that's quite helpful, but it's not really readable as it is. So what we could do is, if we wanted to get to see them separately, we could go for I in sys.modules, and then basically print, I, and if I press enter it will print all of these out, not the locations, etc., but just the actual module names that are in there. So near the top ish, we should find the OS, which is here, so like so. So there is other libraries that you probably have used. You might have used the ref or regular expressions, threading, which I use regular, time, and Tkinter because I like doing my graphical user interfaces, the math library, etc. So yeah, there's quite a bit in there. There is the sys.builtin, I think it was module names, was it? Yep, there we go. So that tells you about, I'll just press enter a few times to bring it up. I'm just going to jump in on this video. I'm just going to slide this in because I missed out the function getsizeof. I realised after I'd finished recording and watched it back, just as a check, but I'm just going to slide this in here. So getsizeof, you would think it would be something to do with the size of a file, but it isn't, as I found as I tried it. So if I do sys.getSizeOf, and it's asking for a object. Let's presume, well, like I thought, that it may be something to do with a file, so I'll give it a full file path. And if I call test.py, which is a Python file that I create in this video coming up in a moment, when you get back to it. So if I press enter on there, it's returned as 41. That is a value of bytes. So is it a byte value of the size of the file? So let's have a look. I'm just going to bring up a terminal window. It is in this directory, so if I do ls-l, and I just want to look at the test.py file rather than pulling everything, and you'll see that it is 170 bytes. This here is it's giving you the information of get size of, and it's what you pass into it as an object, not as a file, as I first initially thought. So if I pass in hello, there you go, it's giving me 30 bytes for that bit of text. So if I put more characters in there, my name is Martin Parker, and if I press enter, it's giving me more bytes now. So there you go. I just thought I'd slide that in there. So I'll put you back to the other video now. Thank you for watching. There you go. So you've got this functionality as well. I'm just going to call the directory of sys again, just so I can see what I'm looking for. Right, let's have a look at the executable, and I'll show you an example on how you can use this. So if I call sys.executable, it'll return what you're using. Now I'm using Python 3.7.3 shell. People may still use Python 2.7, etc., but it's not really maintained now. It's considered as obsolete. So yeah, Python 3 is what we're currently on. I think as of to date, I think it's Python 3.9 that's running, possibly. I don't know, 3.9 point whichever. I'm using 3.7.3 on my Oak Pi laptop, but let's have a look at what this means in regards to how you can use it. Like I say, you may have heard the word or the phrase shebang, and that's a form of what you would put at the top of a file. So I'm just going to bring up a file, and how you'd write your shebang would be, if I just move this over, you'll see that of a bit of text. So you would start with a hash, and then what the class as a bang as the exclamation mark, and then you can put in your as it's down there on the other window, so usr / user / bin, and then Python 3. So there we go. And what we'll do is we'll import the sys. Yeah, we'll just do that just as a quick example. So we'll say hello, and then we'll print out the sys.version. Okay, so it's very straightforward, very basic, but it is a script and we need to save it. So we'll call this test. And as you can see, it has printed out the version after the word hello. Very straightforward, no errors, as is what you expect. But if we bring up a terminal window, and if we do a similar sort of thing, so if I type Python, it will give you the default, which is Python 2.7.16 on this Raspbian operating system. And if I import sys and then call sys.executable, now you'll see that I have a different location. Basically it's missing a number 3 at the end, so that is how you would work that. But if I quit out of here and if I call Python 3 shell on screen, and now if I import the sys library, and then do sys.executable, and there we go. So that is what we are set into our test script. So I'm just going to quit out of there. Right, if I call the Python as it is, and then / and then the test.py, you'll see that it's the run the Python, because we've told it to do Python, and when you just pass Python on its own, it will try and do it as 2.7 version. But if I make this executable by doing chmod and then +x, and then passing the file name, which if I do ls-l and then test.py, rather than showing everything, you can see that this file is read, write and executable. And now if I do / and test.py, you'll see that we have it running as it's told, and that's how you can use the shebang line to force it to do a certain version. But I can still do the Python and then test.py to force it to do it via 2.7. But when you make something executable, you don't really want to have to tell it to run it as a Python. That is the reason why you have the shebang line, so that it knows on which executable to run it as. So that is what the executable of sys helps you out with, the location and how to enter it. So that's that example. So let's look at the next one that we're going to look at. So I've done executable, I've done the built-in module names, I believe. Yep. So that's that. Right, argv. Right, so let us bring up our test script again. Might as well, let's pick on our test script. So we've got it set for that. We've got the sys, and yeah, what we'll do is we'll import our favourite time language library. I keep saying language, and we'll just get rid of all that. And what we'll do is we will get a, we'll set it as a, is equal to sys.argv, and it's just going to call that. And if we print a, you can see that we're getting it that way. So if I run this, you'll get there. So this is the window, and it's returned as a list, and it's basically the file location from the file that we're running as a full path. If I run it via a terminal window, bearing in mind if I do print working directory, you can see where we are, but if I run that test.py, you'll see that it's returned differently to the Python shell because we are in the home py directory and it's returned as that. Now the reason why argv can be quite useful is if I bring up my Python script again and I get rid of that, and if the len of a is not equal to 1, because it's going to be 1, because the first argument will be the actual Python script, or the script name I should say, and then we'll print, what should we print? We will we will call b is equal to a, all of them basically. So it's going to pass in the rest of the no, we'll go with the next one, because the first one, index of 0, would be the file name. So we're going to grab the second one, the index of 1, and we are going to do a for loop. So we'll do a for I in range, and we'll pass in, if I can spell it, it would really help. We'll just do it 5 times, and we shall print out what we pass in. So we'll print out b. We'll just put it as b, and it'll run, and it won't work in the Python shell because there's no way to actually pass in an argument. If you know a way of doing it, please let me know, because I can't see any way of triggering it. But if you do it from the terminal window, so if let's just nano test.py so you get to see it here. So if I just go through it, so you've got your shebang at the top, we're importing time, sys, we're setting a to be the arguments that I'm going to talk about in a second. If a is not is not 1, so there's more than one argument passed in, the second one will be the how many time, we're going to print it out 5 times basically. So if I control X out of there, and now if I call the test.py, helps if you spell it correctly, nothing's happened, just like when we did it via the Python shell. But if I call up here and if I pass in hello, right, now it's printed out. I didn't set the I didn't set the time, did I, between each one, so I'll do time dot sleep and we'll just pass in a second, just so we've got some to run by as a time. So there we go. That is how you can use argv using the sys module on how you can grab, and you can grab as many as you need to have. So you can print out the len of A, and it will give you that information. So we could, in theory, pass in hello. Now these are spaced out values. These are classes, these arguments. So this one here would be the script's name, so that's argument 0, and then we've got argument 1, and if anything I pass in after here, if there's a space in there, it will be classed as an argument. So if I put hello, my name is Martin, okay, and if I print that, it's going to go through them, but it's all going to print out hello. But you see how there's 6 arguments, so 1, 2, 3, 4, 5, 6, and I misspelled my name. Well, I didn't spell it wrong, I just put the wrong letter, the wrong case. But if I was to pass this in as a string, okay, and then press enter, this is being classed as one argument because it is a string. And now you'll see that there's 2 arguments being passed in. So the first one being index of 0, or the first one passed in is the name of the file, and then the second one is what we put in. This case we did it as a string. I hope it makes sense. I know sometimes I do slightly waffle on a little bit, but I'm trying to get you to understand on how you can pass in extra stuff. So I can pass in digits in here, and it's slightly off of picture, and I can do anything. So what I could do is, as part of my script, I could use these other instances that I'm passing in as an argument and work that into the code. So there we go. So rather than doing that, we shall do we'll go with A1, so we'll pass that in there and we'll set that to 2, and we will save the script, and if I pass in here, so I've got my script, and how many times do I want it to run, because this is the way that we've set this code. So the first argument, which is test.py, is the first argument, and then the second one is how many times we're going to print out the third argument. So if we go 2 and then we pass in a string, thank you for watching, we'll pass in there, and it's classed as a string, so we need to set that as an integer. I do apologise. So save that, and if I call that again, there we go. So thank you for watching. You even see all my mistakes that I make. I don't edit anything out, and that's why sometimes I make mistakes. And if we want to change the amount of times we want this to print, so we're going to put 5 and change the text. A little quick and cheeky text, so let's pass that in. So please like the video if you found this informative. I know sometimes I do make mistakes and I get myself mixed up, but I do come good in the end. So there you go. Thank you for watching. Please like the video if you've found it informative, and share it for anybody who it could benefit. So thank you for watching, and I'll catch you in the next one.